Yeah, question 10, we have a differential equation. So, a spherical mint of radius 5 millimeters is placed in the mouth and sucked. Man, did I laugh on the first 97 times filming that. 4 minutes later, the radius of the mint is now 3 millimeters. In a simple model, the rate of decrease, that's going to be important. So the rate of decrease of the radius is inversely proportional to the square of the radius. Using this model and all the information given, we want to find an equation linking the radius of the mint and the time. We should define the variables that we use. Okay, so 5 marks. So first up, let's think about the variables that we're going to use. I would use R for the radius. So let R be the radius, and I would also use T for time. Now, it is important what unit, so we are told that 4 minutes later, so we're going to let T be the minutes, since the mint was placed in the mouth and sucked. So since the mint was placed in the mouth, okay, now let's go through and pick out the important parts. So, at the start, a spherical mint of radius 5 millimeters. So that tells us when T is equal to 0, R is equal to 5. Now I suppose maybe when we've defined R, we should say it was the radius in millimeters, just to be nice and clear. Now we're also told 4 minutes later the radius of the mint is 3 millimeters. So when T is 4, R is 3. So we got 2 sets of conditions. Now the next thing would be that we're told the rate of decrease of the mint. So that's going to be the rate of change of R over time. So that's going to be a derivative. It's going to be dr over dt. Now we're told that that is inversely proportional to the square of the radius. So first we should say that is proportional to 1 over r squared, and then the formula we would use is dr over dt is equal to k over r squared. Okay, so now we are set up. We now want to find the equation linking R and T. So we're going to need to split the derivative, so get R's on the same side and T on the other. So if we multiply by R squared, we get R squared dr, and we're going to multiply by dt is equal to k dt. So now we're going to integrate both sides, so we get, so if we stick integrals there, so on the left we're going to get r cubed, and on the over 3, and on the right we're going to get kt add a constant c. So what we now need to do is find the values of k and c. Now this is when the conditions come in to help us. So we know that when t is 0, r is 5. So t equals 0 implies that 5 cubed, so 125 over 3 is equal to c. So c is equal to 125 over 3. Okay, so that's the value of c. Now we need to think about, first of all, before we find the value of k, we need to think about what's actually happening to the mint. The radius is decreasing, so the kt part of the derivative has to be negative. If it was positive, it would show as a rate of increase, so we need it to be negative because we are talking a rate of decrease. So because dr by dt represents a decrease or a rate of decrease, we know that kt has to be less than 0. It has to be negative. So we can find the value of k by substituting in when t is 4, r is 3. So when t is 4, r is 3, that gives us 3 cubed is 27 over 3 is 9, so we get 9 is equal to k times 4, so 4k, add 125 over 3. Okay, let's multiply through by 3, so we get 27 is equal to 12k, add 125, take the 125 away, we're going to get 27 minus 125 is going to give us minus 98, so that's good. K is going to come out negative anyway, so we get minus 98 is equal to 12k. So if we divide by 12, k is minus 98 over 12, which has a common factor of 2 and gives us minus 49 over 6. So we can say r cubed over 3 is equal to minus 49 over 6 t add 125 over 3. We can make that look a bit nicer. If we multiply 3 by 3, we get r cubed is minus 49 over 2 t add 125. Cool. Okay, then part B. For 2 marks, hence find the total time taken for the mint to completely dissolve. Give your answer in minutes and seconds to the nearest second. Okay, so when the mint has dissolved, R is 0 because the mint no longer exists. So that's going to give us 0 is equal to minus 49 over 2 t add 125 add 49 over 2t, so that is 125 times by 2 divided by 49, t is 250 over 49, which is 5.1 minutes. Now, 0.1 times 60 is 6, so that gives us 6 seconds, so it's 5 minutes, 6 seconds. Okay, and then the final part for 1 mark says to suggest one limitation of this model. So I would say the biggest one is that we've assumed the mint remains spherical. We've also assumed that the mint is solid and not hollow on the inside. We've seen that the model that we've got only works up to 5 minutes 6 seconds. We haven't taken into account if the mint is bitten or swallowed. Is the mint moved around the mouth or does it just stay in one position? That's going to affect things. Temperature of the mouth, that's going to affect things. Anything along those lines, and you're cool. Cool.